It's already recording. All right. So, everybody okay with those? This one often causes people trouble right in there because there's a negative number there, and people are like, "Oh, there's a negative number there." Well, right? But if you think about it, it's not complicated, right? Because this 3, since it's got a negative base, whatever is in there is going to be negative, isn't it? Right? And then that negative is to the 4th power. And a negative to an even power becomes positive, right? So this ends up being x, positive x to the 12th. So they end up having the same base. Everybody cool? Okay. So I have negative x to the 3rd. Right, Jessica? Okay. Whatever value I put in there for x is going to end up negative, isn't it? Right? Because this negative is not part of the base. You with me? Okay. So this will always be a negative value, right? No matter what. Now, negative x to the 3rd was to the 4th power, right? So now I have a negative to the 4th power, right? So that is going to be a negative times a negative times a negative times a negative, right? 4 negatives make a positive, right? So once I put this to the 4th power, even though it started negative, it's going to end up positive. So what this is saying is negative x to the 12th, because the negative is part of the base now, is the same thing as x to the 12th.
I'm just confused at how you got the x to the 48 power and then you made it to...
Okay, well, once we got 16 in the brackets, cubed, you multiply over the bracket, x to the 48th, x was negative 2. Okay? And it doesn't even work on your calculator. It's scientific notation. There's no point in showing it to you. It's a big number. It's like 2 trillion. Okay. Everybody good? It's a real tricky one. But again, it just comes down to knowing everything about exponents, right? That's my radius. Does everyone, people who did it, agree with that? I did it in my head. Is that around what people have? I mean, I could get out a calculator if I need to. Nobody has anything like that? There's a chance I did it wrong. Let's check. The volume is 425. That's the formula. So I multiplied both sides by 3 to get 1275. I divided by 4 pi, which is about dividing by 12, right? Yeah, that's right. I did it in my head except for that. Oops. All right, and this one I have 2.6. It's the exact same thing. It's just doing algebra, right? You need to be able to do algebra in a pre-calculus class. I'm just moving stuff around. The trick here was the height and the radius were equal. So I changed the r from the formula to an h because h and r were the same. Once I have h and r the same, that's the same base, right? So it's h cubed. Cool? All right. Everyone is good with page 16 this was, yes? 15. This was 15. Okay, here's 16. Here's the answers. I will explain any one of them that you wish to have explained because, of course, they are all the same, right? If you can do one, you can do them all. So if you have any of those wrong, ask me now, and I'll run through that for you. It's on YouTube, Jessica. Oh, okay. All right, fair enough. Michaela, Bryce, my coffee's still too hot.
Are you blaming me or are you just informing me?
I'm informing. No. When it asks for a radical, that means we do that thing we did where we take the exponent, the fractional exponent, and we fix it up. Then you do your exponent laws. So you need to see one of these, right, Michaela? Okay, let's do the very first one. Yep. Okay. So this right here, this guy, A, that is really x to the 3 halves times x to the 2 halves, yes? Right? Now, since those are the same base, we can add the exponents, right? So 3 halves and 2 halves is x to the 5 halves. Okay? Everybody cool? And then there's an exponent, x to the 5 halves. And then as a radical, it's the square root of x to the 5th. Everybody cool? Now, here's something that I forgot to show you guys because it's something that I automatically know and I forgot to tell you guys. This construction right here, x to the 5 halves. Some textbooks will write this as the square root of x all to the 5th. And some textbooks will write it as square root of x, and they'll put that 5 in with the x. They're the same thing. Okay? Everybody understand? We're good? Okay. If you need that proven to you, I can show you, or you can just believe me. It's up to you. If you want me to prove it to you, I can. Everyone is okay? All right. Is everyone okay with those 6 answers? Anybody want to see any more than the first one? They're all the same, right? I mean, it's just converting to fractions and adding fractions. It's really taking you back to Mrs. Bagcrumble's grade 5 class.
Do you want to do that?
Yeah, sure. F is x to the 3/6, yes? Which is x to the 1/2, yeah? And the other one is x to the 2/4, which is 1/2, yeah? So x to the 1/2 times x to the 1/2. I add 1/2 and 1/2. It's 1. X to the 1 is x. Okay? Don't be fooled by looks. Here are these ones. It's all the same thing. Now, you guys need to be aware of something. I do these in my head in about 20 seconds, right? You'll notice I have no work written there. It's possible I've made a mistake. I'm only gorgeous, funny, and smart. I'm not perfect. So if you have something totally different from me, by all means, question me. Because sometimes I will be wrong, and sometimes I won't be. But that's what I'm here for. Michaela. I know, it's tough to read. I did it as 1/2, but if you did it as 3/2, then it's x to the 5 halves, again, so it's the square root of x to the 5th. Either one. The point, Michaela, again, is not whether you have that answer or not, it's if you did the right stuff, right? So if I gave you a test, and you did a whole bunch of work, and it was all right for the work you wrote down, I'm not going to dock you because you read a number wrong. You understand what I'm saying? That's why I ask you guys to show work. I mean, if you just wrote something and it was wrong with no work, I have no idea. I have to assume you're a doofus and you don't know what you're doing, right? But if you did all this work and said that was a 3, obviously I'd give you full credit, right? Everybody okay with that one? Those 2, 4, 6, 8. It's the same thing again, right? It's just adding fractions. Yeah? Okay. Now the next one is where we get into a bit of trouble sometimes. There they all are. I will again highlight. I mean, I know you guys have eyes and you can see. You're not... This is like the last thing we did in our notes. Again, if you have something different than me, check. Jessica? H, you would like to see, okay? Anybody else? Anything before H? That's 1,000. That's 400. No. All right, so H, 60, negative 64 to the 2/3. So negative 64 to the 2/3. Now, the negative is part of the base, right? So that means I'm looking for the cube root of negative 64, not the negative cube root of 64. I want the cube root of negative 64, and then I'm going to square that. All right? Now, since it's negative, and it's a cube root, it must be a negative answer, right? So the cube root of 64 is 4. 4 times 4 times 4. But I need it to be negative 4. Because negative 4 times negative 4 is positive 16 times negative 4 is negative 64. So this in here, which I will highlight in blue, is negative 4, yes? And that's inside brackets, right? And that is then squared. So a negative squared, negative times a negative, positive 16. Cool? Okay, everybody good with A through, oh. G, this one, yes. 36 to the 3/2 means I want the square root of 36 cubed. Square root of 36 is 6. 6 cubed. 6 times 6 is 36. 36 times 6 is 216. Good? All right. 17. Oh, negative exponents. Blah. But nothing changes, right?
Did you just,
I just highlighted them all.
no, I didn't say it. Did you just put the exponent?
Yeah, you just do the work normally and then put it under 1. That's the easiest way to do it, right? So let's just look at that first one. Most of you probably did this. Okay, 27, oh, it's got a negative exponent, so it's got to be 1 over 27 to the 2/3. And then it's already ugly, right? What I would do here is I would say, okay, self, this is a negative, so it's got to be reciprocated, all the work I do. So I'm going to do 27 to the 2/3, which is the cubed root of 27 squared, which is 3 squared, which is 9. But that exponent was negative, so I got to reciprocate this and make it 1/9 at the end. Everybody understand? Now, could you do it with the 27 in the denominator? Of course you could. It's the same thing. It's just tidier on your paper, maybe, when you're showing your work. Do you want me to do a couple more of these? Because I see a bunch of people writing right now, which means a bunch of people probably left 1 or 2 of these blank. Should I do a couple more? I understand if you forgot to do it. It's fine. But if you did it and you don't have these answers and you'd like to see, that's 27, by the way. I know, right? And that's 8. 1/8. And that's 1/1000. Does anybody want to see another one of those? Are we okay? When there's only one negative exponent, you can just do the work as if it was a positive, then reciprocate at the end. Okay? Sweet.
Do you want to do C for the next question?
Yeah? Down here, you mean?
Yeah.
Yep. So let me get it set up. C. That's 125, not 175. C, which is 81 to the 0.75. Oop, not 0.75, dummy. 0.75. Okay, that's 81 to the 3/4, right? 4th root of 81 cubed. 4th root of 81 is 3, because 3 times 3 times 3 times 3. 3 cubed is 27. Okay? Now, guys, I realized after I assigned this to you that this part of the question makes this very difficult for you guys because you haven't done math in a long time. And maybe you don't remember that the fourth root of 81 is 3. And I forgot to review for you how to find roots without your calculator. Understand? I forgot to do that for you because my very next unit is that, but more complicated, right? The very next thing we're going to do is radicals, but they're more complicated. And then I was thinking to myself, as I made this up, oh, they'll remember how to do this. But I think some of you maybe have forgotten how to do the fourth root of 81 without a calculator. If you've forgotten that, that's cool. I'll show you right now. Is your hand up for something? Can I do B? Sure. Should I do B before I do this? Do this first. Okay. Remember, 81, we break it down 9 and 9, 3 and 3, 3 and 3, right? Product of primes. The index number tells me how many I need. It tells me I'm looking for a group of 4. There's 4. So the answer, all 4 of them come out, but they come out as a group, so the answer is 3. Remember? Everybody remembers this now? Right? I tried to keep all the answers to 2 and 3, because most of you know the first few roots of 2 and 3. Or the first few exponents of 2 and 3. Right? Okay? I really recommend knowing up to 5, at least up to cubed. Like know that 4 cubed is 64. Know that 5 cubed is 125. I really recommend that. 6 is even a good one to have because 36 and 216 show up a lot. Okay? Now, Sydney, you wanted to see 16, or B, I mean? Okay, 16 to the negative 1/2. So that's 3 halves, yeah? I'm going to do the work with a positive, but I'm going to remember that I need the negative at the end. So that is the square root of 16 cubed, right? Oh, I screwed it up. Yeah, I screwed it up. See, good thing you checked. Square root of 16 is 4. 4 cubed is 64, right? So it's really 1 over 64. Nice job. No, don't doubt yourself. You take time and do the work. I go blah, right? Because I got to keep up with you guys. Nice job. Now, right here is about when somebody should say, if he screws this up in his notes, is he going to screw up marking our tests? It's possible. That's why I give you your tests back and go over them with you. Because every so often you will find, holy crap, Myers made a mistake. It happens. Just like it happens when you guys make mistakes. Everybody okay with this one? Marcus. H. Yeah, I better check myself. Because H is a tough one. So I've got negative 1/32 to the 0.8, which is the same as negative 1/32 to the 4/5. Everyone's cool with that, yeah? Okay. So this means I'm looking for the 5th root of negative 1/32 all to the 4th power. Everyone agree? Okay. The 5th root of negative 1 is negative 1, right? Because negative 1 times negative 1 times negative 1 times negative 1 times negative 1 is still negative 1. Agreed? So I'm going to end up with negative 1 on top. Now I need the 5th root of 32. It's 2. Because 2 times 2 times 2, 2 to the 5th is 32, right? So this is negative 1/2. Agreed? Okay. And then it's to the 4th power. So it should not be negative because it's the 4th power, right? So it should be positive 1/16. Thank you, Marcus.
Are you questioning yourself now?
No, it's just a missed negative. Again, this is what you guys need to see, that the process is more important than the number, right? But question, please do. Don't assume that I've rocketed through this perfectly. While you guys were working on this, I did the key, right? All right, what do we got? Is that it? All right, so you guys are moving on to page 18 now. So you guys work on basically the rest of the package until page, what did we say it was? 27. And I'll walk around and help. One sec, Bryce. I'm just going to... Because 28 is barfy. Okay. If I were doing this, because remember, you have to look at every exponent question as its own thing. You apply the laws to it. Don't apply the laws in a set order, because sometimes it makes sense to do things in a different order, as long as you do all the right laws. Okay? So what I would do here first is I would deal with this, because that 5 applies only to these two exponents. Okay? So what I would get here is I would have bracket negative a to the 30th, right? I have to leave it negative because the negative is in the base and that's an odd exponent, right? And then this would be b to the negative 30. Now some of you right there are seeing a negative exponent. You want to move it. Should we? No, because there's so much other stuff to do. And then that is going to multiply by negative a to the 4th and b to the 0. And that whole thing is going to be cubed. Now that 3 now applies to everything in the brackets, but I can simplify in the brackets right now, can't I? So what am I going to get? I'm going to get negative a to the what? (34), because I add the exponents. And negative 30 plus 0 is... It's not a trick question. It's negative 30. And then all of that is cubed. So I get negative a to the what? What do I got to do with 3 and 34? What? Multiply. So it's 1 what? It's 102. Okay. And b to the negative 90, correct? And now I got to bring this guy down to the party. So a to the 4th, a to the 102, right? And b to the 90. And what do I do there? I just add, right? Everybody cool? Okay, I'll pause the recording, then I'll start coming around and helping again. Oh, where did it go? Where did it go? Where did it go? Where did it go? Kelvin. The exponent. Yeah. Yes. 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 Yeah. The whole thing is still negative. Negative somewhere up there. Remember, guys, when you move something because of a negative exponent, only the exponent changes. The base doesn't. Negative 2 to the negative 3 is 1 over negative 2 to the positive 3. Yep. That's a 1. So 1 plus negative 9 and then you're right. Then the 80 goes down below.
For this,
Did
where,
you just, was it you?
yeah.
Okay.
For this, where it's 2 times a to the 6 big difference, does that just become 4a6b3 because it goes to both when we put it together, or does that not work like that?
It's 2a6b3.
Mm-hmm.
Yeah, that's all. That's the answer. So what do you ask me? I'm sorry, I don't understand what you're asking me, Bryce.
Oh wait, I might have just kept unnecessary brackets.
Yeah, you kept unnecessary brackets.
Yeah, never mind.
Because once you simplify that, the brackets are gone.
Yeah, just
A
actually
to the 6, B to the 3.
Never mind.
Yeah.
But if
And
but just for reference, if there had been brackets there and I just reduced both, could I make that 4, but then just keep the variables times by each other, or does that not work?
I don't think it works because I still don't really get what you're asking.
Well, if it goes,
So if you're asking me if you had something like this,
to a whatever,
A3, B3.
Sure.
Okay, well that is 2A3, B3. You wouldn't ever need those brackets. Okay? If you had this, a 2 in there, you understand?
Yeah.
Then it would be 4A3, B3.
Okay.
Okay? Now if you had A out here, it would be 4A4, B3.
Yeah, okay.
Got it? I think between the two of us, we answered your question. Back corner, how are we doing?
Great.
Nice. Other back corner. Okay, now. What does that negative exponent do to the negative 2? Where do negatives go? Right, so write the fractions you have. No. Negative 2 goes, the whole base moves down to negative 2 in brackets, but the base is negative 2. Now, what is negative 2 cubed? Negative 2 times negative 2 times negative 2. Right. So the answer is 1 over negative 8. That's this one. You've got your own book, man. So what? You're just not checking. They're slightly different. So you're missing a whole bunch of things. Yeah. I added till there's a unit. Yeah. But yeah. You know what? Yep. Bases don't change. Kelvin. That is saying this.
Oh, never mind. It's like 7/3.
Yes. Okay, that is saying this. 7 to the 3rd 4 times. Right? So then you would add them up. It's 12, right? But the shortcut to adding the same thing over and over again is multiply. That's why we multiply over exponent. That's why the law is what it is. Okay, now you can look at the snow.
Oh, come on.
Holy crap.
I don't want snow.
I don't want it either.
Now you can look at the snow, because now it's something more like.
I like it fun. I could, but I don't want it.
That's because those geese should have left. But global warming is messing with them. Those geese are like, why the hell would I fly all the way to Florida? It's warm here. My idiot son also only wore a hoodie to school today. I drove him.
He's wearing this.
I know. I drove him to school. I said, boy, you're walking home. It's okay, Dad. I got my toque.
Hey, this is what I did to my dad. My backpack.
I bought him a new toque at the Arkells concert. He's got an Arkells toque. Oh, crap.
Is that down?